Okay, now that we know what inverse functions are and how to find them, we're now going to be talking about their properties a little more. So in this section, you'll see several learning goals that look similar to last, but they will be just a hair different. We want to be able to find the inverse of a relation, so we're going to get more practice on that in all the different forms: point, chart, equation, and graphs. We want to apply those properties of inverse relations and functions, and then we want to make and interpret graphs of inverses of relations. So let's get started, since we know a little bit about what we're doing, but let's look at the new pieces that are our valuable notes from this section. So with this, two functions, f and g, and it doesn't matter really what they're named, are inverse functions if and only if. And notice it says 1 and 2, and you got to do them both. For all x of f, you have to do g of f follows f of x, and it has to come out to be x. And you have to do f of g of x, the composition, and it also has to come out to x. So what that says is, whatever you started with in your function, when I say started with, there's the x, that's my starting point. That also has to be my outcome. And if it's not, then these two rules are not inverses of each other. All right, this is where we also go back to our matrices. Remember when we had a 2x2 matrix, for example, and we said find its inverse, and you had a way to do that. This M inverse is our notation. Do not forget that f to the negative 1 power is the inverse of a function. Okay, and remember our different ways to find inverses, because that's going to be crucial. We're going to be working, though, a lot with equations in this section. All right, so we're going to apply those. So with this, we've got three different things here, so let's do them one at a time. Let's attack them. So our rule, f of x in arrow notation, says I need to take half of x and then subtract 3. So it says find a rule for f's inverse. So let's write it, because some of you are not used to arrow notation. You like f of x notation a little better. Let's write it in f of x notation. So f of x is equal to, what's at the end of the arrow is your rule, so 1/2 x subtract 3. So there's your equation. That's what you want to work on. If we were graphing that, though, remember f of x always means y. All right, so if that's the case now, and it says find a rule for the inverse of f, that's definitely where we want to switch it and put the y in. So if we're looking at y equals 1/2 x minus 3 is our original equation, then when we write the inverse, we're going to do our immediate definition, which says flip-flop x and y, so it would read x equals 1/2 y subtract 3. That's face value. That's not going to be acceptable. You need it with y by itself, because that's what we use most cases in our algebra. So let's move the 3 to the other side. That would give us x plus 3 equals 1/2 y. With our 1/2 y, what do we want to do? Get y by itself. Good choice. So to get y by itself, you're going to probably have to multiply by 2. Now be careful on this side. That's a whole term, so when you multiply by 2, that's going to change things on the left. So cleaning it up on the right, we get y. Over here, we would get 2x plus 6. So our new equation in inverse form is y equals 2x plus 6. So you might want to, on your paper, if it's starting to get messy, make sure you have it labeled. That's the inverse, and then you know you have your original up top. Okay, with that, it says find f of inverse of x, and then the other one, f's inverse, follows f of x. So if we use this and try to use the definition to find out if these are really functions. Now, we just did it, so we really know they are, but what if you had two that weren't? So let's show you that process. Again, let's write our f of x notation, which again is more comfortable to some of you, and over here it would be f's inverse follows f of x. And since we have equations now, we can put those in. So f's inverse was nothing more than 2x plus 6. So we're going to put that inverse in. Remember, that's a number, represents a number. And so now we need to take that 2x plus 6 and put it into the F rule. Back up top, our F rule was take 1/2, put your number in, that's the 2x plus 6 part, and subtract 3. We'll do the math on that. In order to finish this one, let's put the shade away, we would have to distribute. 1/2 times 2 is 1x. 1/2 times 6 is 3. And 3, take away 3, leaves us with just 1x, or as some of you would say, x. So when we did F follows F's inverse, we got a final answer of that x value that we started with. So it basically shows that those two are inverses. Let's do it the other way. F of x has to be our starting point. Well, our f of x, I sort of took off the board there, but f of x is half of x subtract 3. So that's what we're going to start with. 1/2 x subtract 3. That number now has to go into the inverse equation wherever there's a variable. Our inverse equation is sitting up here, top left, 2x plus 6. So we're going to put down 2 times, there's our number, 1/2 x subtract 3, and then plus 6. All right, let's do the math. 2 times 1/2, again, 1x. 2 times -3, -6. Plus 6, add those together, we get a 1x. 1x equals x. And again, when we did our f inverse follows f of x, we started with an x, and we also got an x out. So that shows that these two things were definitely inverses of each other. But the question will be, what if I don't know that they are? That's something we'll explore. On this one, if f of x equals x to the 2/3 power, and g of x equals x to the 3/2 power, and the domains of f and g are the set of non-negative real numbers, so that basically is telling us we're only going to put in positives or 0, the question is, are f and g inverses? So I believe it's really asking us to do what we just did on the other slide. Whoops, let me back up and write that a little different. So we need to do f of g of x, and then we need to do g of f of x. Nice. So here we go. G of x is the function x to the 3/2. That number needs to be put into the f rule wherever there's a variable. Oh, there it is. Our variable is, or our function rule is x to the 2/3. So x to the 3/2 is my number. That's being put in to the 2/3 power. What do we know about power of a power? We learned that you just multiply them. So top times top, bottom times bottom. We get x to the 6/6, and x to the 6/6 is the same as x to the first, which we know is x. That one's looking good. We started with an x going in, and we got an x coming out. So far it looks good. You can't stop, though, just because one of them looks good and say, oh yeah, they're inverses. You need to do them in both directions. So in this case now, f of x is our starting point, so x to the 2/3. And that number needs to be put into the g rule wherever there's a variable. Our g rule is x to the 3/2 power. So put our number, x to the 2/3 in, and take that to the 3/2 power. And again, do the math, power of power. 3 times 2 is 6. 3 times 2 is 6. X to the 6/6 reduces to x to the first, which is just x. And again, what we started off with as our variable is what we got at the end. So yes, we have just shown that these are truly inverses of each other. They won't always be, so that's what you have to watch out for if you try to guess. Like on this one, you look at it and some people will say, well, f of x is times by 3 and g of x is divided by 3. Those are inverses, and that's a +2 and that's a -2. Well, they're inverses, so sure, they're going to work. All right, so again, let's try it and see. you have to do f of g of x in one direction, and then in the other direction you have to do g of f of x. Again, keeping in mind that we started with an x value, we need to get an x out. All right, here we go. We'll do the one on the left first. Find our g of x. Well, our g of x rule up there says take 1/3 x and subtract 2. Take that number, because that's all it really is, and put that into the f rule wherever there's a variable. Well, the f rule says take 3 times by your number, so that's where we put our 1/3 x minus 2, and then add 2. Now, order of operations, we definitely have to multiply first, so 3 times 1/3, 1x. 3 times the negative 2, negative 6. And we still have that plus 2 on the outside. Let's do a little more math. 1x subtract 6, or negative 6 plus 2 would give us a negative 4. All right, we've got a 1x minus 4 as our final result. Now, first thing to notice is that's not what we started with. So some of you would say, I'm going to quit right now because according to the definition, that didn't work. Let's just show you that if you would, have done that, maybe you could. Let's do this order, and then we'll draw a conclusion. So now g of f of x means start with the f of x rule. So we're going to replace f of x, and we're going to put the rule of x plus 2 in. Now that's a number. So we will take 3x plus 2, and we will substitute that into the g of x rule wherever there's a variable. So I'm starting to copy the g of x rule. Here's my variable of x, and I will put in my number 3x plus 2. And then I will subtract 2. Again, clean it up. 1/3 times 3x, 1x. 1/3 times 2 is plus 2/3. And then we have the subtract 2 on the outside. Again, remember that in order to add a whole number with a fraction, you really want to rethink this 2. 2 is how many thirds? How many thirds if you're in cooking class? So we're going to rethink of that as 6/3, so rename it, and now finish the math. If we finish the math, we're going to get 1x, because that's the only x in the problem. Whoops. 1x. And that 1x should give us a 2/3, take away 6/3 is a negative 4/3. And again, we have a slight problem, because that was not what we started with up here. And so in this case, it didn't matter which half we did first. We are not getting back to the original. Those two equations at the top, even though they looked like they were inverses, show by this substitution method that they are nowhere close to being inverses. They don't undo each other, even though they did look like they did in the beginning. So remember, the rule is f of g of x has to equal x, and g of f of x has to equal x. So you do the rule in both directions. You have to get back to what you started with. We are not getting back to what we started with here, so we do have a problem. All right. Show that f of t equals 1/4 t minus 3, and g of t, which equals 4t plus 12, are equations for inverse functions. Okay, again, f of g of t, g of f of t. In order to show two things are functions, you have to be able to go through this process. And it is a substitution process, and it's like two mini problems. So here we go. Starting at the top. See if you can stay a step ahead of me. G of t. G of t is nothing more than the rule. Take 4t and add 12. That number now has to go into the f rule wherever there's a variable. Well, the f rule starts out 1/4 times t. So that number, 4t plus 12, goes in for t. And then we subtract 3. Let's clean that up. We got some algebra we can do. We've got 1/4 times 4 is just t. 1/4 times 12 is 3. And 3 take away 3 leaves us with a t. That one is actually looking much better than our last example. Started out with a t, and we got a t. But don't stop because you've only done the evaluating in one direction. Now go for the other direction. F of t now is the original rule, 1/4 t subtract 3. That has to be considered a number, and that number now has to be put into the g rule wherever there's a variable. So I'm going to start copying the G rule for, there's the variable t, so we will put this number, 1/4 t minus 3 in, and we will do the arithmetic. In this case, algebra distributing, and 4 times 1/4 is 1t. 4 times negative 12, or negative 3 is negative 12. Add the 12 to it. We're getting just 1t, if you just like to say t. And again, it's a yes. Show that there you started with a variable of t. You got out in both cases what you started with. So in fact, these two equations are inverses of each other. So I've done several examples now, and it is, as I said, too many problems to show, and that's the best way for most of you to work inverse functions. So bring any questions you have to class, and we can discuss them or do further examples.